Hey everybody, this is Mrs. Ellsworth, and now we are looking at number 4. Okay, here we go. Calculate the number of atoms that are in 1.63 moles of bismuth. Okay, well, we're starting at moles, okay, and we need to go to number of atoms. So we're starting at Moleville, right there, and we're going to use Avogadro's road to get down here to particles. Okay, so there we go. We'll start with what we're given and put it over 1. Okay, and so we know moles have to go down here. And our conversion we talked about in the last video, that Avogadro's number of atoms, so 6.02 times 10 to the 23rd atoms equals 1 mole. 1 mole. 1. Okay, so here we go. So we've got 1 mole equals 6.02 times 10 to the 23rd power of atoms. Okay, and so we'll go ahead and multiply those out because you're dividing by 1. Moles cancel out. That's great. So you know you did your math right. And you're going to get 9.8126 blah, blah, blah times 10 to the 23rd power of atoms. So we have 3 sig figs, so it's 9.81 times 10 to the 23rd atoms. There you go. Okay, we're going to do one more. We'll do also number 5. Okay, calculate the volume of gaseous water, which is steam, or H2O, contained in we want volume, and is contained in 6.28 times 10 to the 21st molecules. So we are actually going from, let me erase this up here. We are actually going from particles, molecules, right here, and we are going to end up with volume right there. This is liters, of course. And so we need to go to Moleville first. So there's a 2-stepper. Okay, and we can do that. Can't take a journey right across here. There's no road. So we go this way to 1 mole and then that way to liters. So let's go ahead and get started. We write with what we're given and we put it over 1. Always what our first step is. 10 to the 21st, and this is molecules. Okay, and we put it over 1. That's kind of like a great way to get started because it gives you a spacer or something like that so that you know that this is on top and the molecules must be down here. Well, we're going to Moleville. And how many molecules are in 1 mole? That'd be Avogadro's number right here. We're using Avogadro's number to get to 1 mole. Okay, so 6.02 times 10 to the 23rd power of molecules. Okay, and so now we've gotten rid of molecules and we're at Moleville right here, and we need to use this road, 22.4 liters to get to volume. Okay, so 1 mole. Okay, and I know that's good because they're going to cancel out. One is on top, one is in the denominator, and then this is 22.4 liters. Okay, so we'll go ahead and calculate this. Now the unique thing about this is, how do you set this up in your calculator? Well, again, these are fractions. So you multiply all your numerators. There you go. Multiply all your denominators. There you go. And then you divide the 2. And this is pretty nice because you got just 1 down the denominator, so you can multiply these 2, press equals, and divide by that one. So let me do that real quick. And when I did that, I got 0.234. It was actually 0.23367. And anyway, so I rounded this up because I need to have 3 sig figs. 1, 2, 3. And what's our unit? Wow, gee, moles cancels out, molecules cancel out, and there you go, liters. Woohoo! Because that is great, because we know that's great because it said calculate the volume. And volume is measured in liters. Perfect. Okay, there you go.